Hey guys, what's going on? So today we've got another Solana workshop here, and basically, as you can tell by the screen, we're gonna have like a mock version of Twitter that we're gonna build using on-chain Solana data, right? So all these tweets that you're looking at right now, some from Will Ferrell, some from me, are all on Solana's chain. And the flow is gonna be basically you connect your wallet, and once you're connected, you can see the app. So if you disconnect, you won't be able to see any of the tweets. But once you do, you can go ahead and connect your wallet and you'll be brought to your profile if you have one. And if you don't, you'll be prompted to create one. And then it'll load all the tweets. And we can simply write something like, hi there, or whatever, right? And then we can click publish and we can approve the transaction to pay for our tweet to be written to the chain, right? And so once we do that, it'll appear in our feed and we can go ahead and read other people's tweets and like them, retweet them, whatever, stuff like that. So pretty cool stuff. I'm going to show you guys how this is built. And basically, we're taking advantage of Solana's PDAs. So in the README, I've got this diagram here of how it kind of works, right? So like you create a Twitter account that's mapped one-to-one with your wallet. And if you saw my journal workshop, that actually is exactly how we did the journal as well. So it's going to look kind of familiar, but I'll still walk through it anyway, just in case you haven't caught that. And we're going to be able to write new tweets under that profile. And we're going to do this with PDAs and with seed derivations and stuff like that. So in any event, I have these diagrams here to try to show you guys a comparison for what we're doing. So like if you know that my profile ID corresponds to me somehow, right? Let's say that you know that I, Joe, am profile 44, right? So you're going to select from profiles where ID is 44. This is if you're using a database in Web 2, right? And that's going to give you one record. It's going to give you my profile. But in Web 3, at least on Solana, what we want to do is we want to take a look at the profile account that is that we get back from hashing together the word profile and my wallet address. So you think of my wallet address as my profile's ID in a way, or my wallet ID, right? So we take my wallet address, we add it to the seed profile, and we hash it with our program's ID, and we'll get an address. And that's going to give us our profile. And so here's an example of how auto increment works, right? So like if you're looking at Web 2, every time we want to log a new tweet, we take the profile ID of the person that wrote that tweet and we increment the tweet ID, right? And actually, more specifically in Web 2, you would just have a table of tweets and each of them would have its own ID and it would just increment up from one. So, that's kind of how this is going to work. But basically, we're going to have auto increments for each person's tweets. So you can see here is like another example of the hashing algorithm. We're going to use the word tweet, the number that that tweet represents, and the person's wallet address or their profile address, either one. If this diagram doesn't make sense to you, you'll see what I mean as we get into the code. But basically, what I'm trying to articulate here with these images is like what we're doing is very comparable to like indexing data in a SQL database, right? Instead, we're going to use Solana's mechanics to do that. And since Solana stores its data in an indexed account model, almost like a file system, we're going to be able to isolate information into almost like records. And for our case of our app, that's going to be like your profile is going to be a record in like the profiles table, and all your tweets are going to be records in the tweets table, and they'll have a link based on a foreign key relation. So that's basically all that these diagrams aim to articulate. So without further ado, let's get into some of the code. So just to start, there's two versions of this workshop, and we're going to run through both of them today. But basically, the V1 is what I have running right here. And on V1, everything is just index data, right? So like my profile, my tweets, the likes, the retweets, those are also separate accounts. And they're just storing a minimal amount of data. They're just linking like a tweet and the liker, but there's nothing else beyond that. In the version 2, we've taken that same app and we've added the additional functionality of where I like somebody's tweet, they get airdropped some tokens, like the like tokens or whatever, right? And I think I might already have some in my wallet. I'm not totally sure. maybe not. I have a lot of other tokens. Many other. There it is. So there's some Solana like tokens, right? And there's also Solana retweet tokens, right? And so you'll get airdrop those as people like and retweet your tweets. And the cool thing about that is like you don't have to pay anything, right? Like you write a tweet, you pay to create it, and then once it's out there, as people are giving you feedback via likes and retweets, you're getting airdrop these tokens. And then if you guys wanted to build on something like this kind of model, you could have those tokens like unlock stuff or like earn rewards or like rank people up or whatever, right? So it's pretty cool. These are like the fundamentals for doing that. So, in a nutshell, the V2 is going to be people interacting with your content and giving you rewards. So the reason I have it broken up into two apps is because V1, I want to focus on how the PDAs work and how the seed mapping and the data indexing works. And then once we understand all that, we'll sprinkle in how we do the tokens. So starting with version 1, let's go into the program and take a look at some of the Rust code, right? So you can see we've got a number of different instructions. We got 4 instructions: creating somebody's profile, creating a new tweet, creating a like, and creating a retweet, right? So let's take a look at the profile first. If we want to create somebody's profile, and each of these instructions has a corresponding state object, right? So this is a profile account, and this is creating a profile via instruction here. So let's take a look at the account. You can see for starters, this is just the data we're going to keep in there. So the handle, the display name, right? In my case, that's Joe C. Dog and at Joe C. Dog. And then the count of how many tweets that our profile has, and then who's our wallet that this profile belongs to, right? So pretty straightforward. And then to create a new one, we obviously have this function here where our default value for tweet count is going to start at 0, which makes sense. Once you create a profile, you haven't run a tweet yet, 0. Now, this right here, the seed prefix, is going to be an important piece. So this is going to be a seed prefix. In other words, our first seed that represents how we create the address for a profile. And now what does this exactly mean? Well, we were looking at that diagram, and to kind of see this in a better light, I'm going to open our client-side code. And in our client-side code, this util file has all of the functions that we need to interact with our program. So you can see get anchor configs, which is going to just set up our local like anchor setup. It's going to pull in our IDL. It's going to create the program object, and it's going to give us the methods that we can use from that program object to do our different instructions or to load our different data, which we'll get to in a little bit. And then I also included this seed util file, which is not super, super important to understand why it's a separate file, etc. The point is, when you instantiate this object, it'll run all of these get program or find program address functions to give you the addresses for these different PDAs. So it's kind of like a util like convenience thing. But the point is, when you pass in the program, you're immediately going to like store the program here, and then we're going to run this init function, and that's basically going to give us the PDAs for the profile, and then we'll be able to access these functions to get like all of these different PDAs. So we'll come back to this, but that's what this thing's meant to do. It's an ease of use to try to like derive these addresses deterministically so we know where to find these accounts. So the first one, creating a profile, right? Here's where we're going to create this profile, and you can see from the seed util, we're grabbing the profile PDA. So let's take a look at what that actually looks like, and then we'll go back to our program. So if you look at the profile PDA right here, this is where that's being created. So our seeds that we have to pass in, because the way this function works, we do find program address, we pass in a list of seeds as buffers, array of bytes, and then our program's ID. And I've just abstracted some of that away right here. So all you need to do is pass in the seeds because the program ID is going to be the same every time. So our seeds to derive a profile are going to be the seed prefix, which is just the word profile, and then our wallet's public key. And that way, every time we have somebody's wallet public key, like connected to our app, for example, if we just take the word profile and hash it with their public key and our program's ID, we'll get the address of their profile, right? And just so you guys are aware, PDAs don't have private keys. So the reason you use these seeds to create this address is because it's actually a special kind of account that does not have a private key. And for that reason, you don't need to manage any private keys. You can create many of these and you don't have to worry about storing their private keys anywhere. And you can use those seeds to authorize changes to these accounts from inside your program, right? So we'll see how that looks. But basically, the gist of this is that our inputs are going to be that string profile and then our public key of our user of our wallet. And with those two inputs together, we can get the location of the account that stores their profile on Solana's chain. So we're going to use this to actually get back the address for our profile. And then we're going to just pass in our wallet's public key and the system program, and then we will create a new profile. And that will take us to here, right? So create profile. All we really are doing is we're initializing a new PDA. And there's those seeds again, right? So we're telling Anchor, like, we're going to use these seeds to create this address. And we're going to set the data as one of these Solana Twitter profile objects, right? And we already saw what this looks like. It's just going to be those 4 fields where the tweet count is set to 0. And so that's pretty straightforward, right? And Anchor, it's nice because you can just write init right here and tell it what the seeds are going to be, and it will build this, it will create this account for you. And then inside of your function, you can set its data, right? And we already told it this is going to be the structure of it, the space of it, right? And so we can just go serialize the data with set inner. So pretty cool. That's going to be us creating a new profile. And the nice thing is, like we said, one-to-one mapping. So once this is done, if somebody tries to create another profile, it's not going to work because this account will have already been existing, right? So this init operation won't work because using these seeds, that address will already exist, right? So that's creating a profile. Then let's take a look at creating a tweet, right? So if we want to create a tweet, the steps are going to look pretty much the same. We're going to use init again, and we're going to make it a PDA, and we're going to use a list of seeds. But notice here, I've got a new seed introduced, right? So we've got the seed prefix for tweets, which is just going to be the word tweet. And I'll show you that right here. And then we've got some information stored inside of a tweet, right? So who's the wallet that this belongs to? Who's the profile this belongs to? We probably don't need both of those fields, but we'll have them for ease of read. And then what number tweet is this? How many likes does this tweet have? How many retweets does it have? And what's in it, right? And again, we're starting both those counter values at 0 when we initialize this tweet. And so if we go to create a tweet and we have the seed prefix as the word tweet and the profile's address as our 2 starting seeds, because we want to be able to write multiple tweets under the same profile, we don't want to have that collision problem that we have with the profile where we go to create a new profile and the account exists already. So what we need to do is we need to have a new seed, at least in one of these fields, every time we go to create a tweet. So one way you can do this is you can just have a counter. So we know that in our profile, we have a count of tweets, and that's actually set to 0 to start, right? So how about if we go to create a tweet, we just reference that value, add 1 to it, create a new tweet, and then update that value to the current count of tweets. Then what we can do is we can use that value to determine what number this tweet is and use that as a seed so that we can know that we're creating a new tweet every time, but we can still deterministically derive the address of that tweet using that information. So what we'll do is exactly that. We will also pass in the profile. You can see it's mutable. We're doing a check to make sure that it's the proper authority, right? Whoever's signing this transaction. And we're making sure that this profile is brought into scope here so we can load its data. And you can see that we're actually going to use the tweet count plus 1 to determine our current tweet's number. And then once we set the inner for the tweet and it's been created and set, we then just increment that tweet count for the profile. And now we can run this over and over and over again and keep generating new tweets. They'll all be searchable by our profile because the profile is one of the seeds. And as long as we know what tweet count we're looking for, we can derive this address. And so you might be thinking like, okay, well, we probably need to store that tweet count somewhere. Well, yeah, probably. But the way it kind of works on your front end is it depends on how you want to integrate this thing, right? So if you want somebody to be able to search a tweet, That's where things might get a little tricky. But if you want to show all tweets and you load all these accounts into your front end, and then you want to like click on it and be able to do something, you've already got all of its information rendered, including its address, but also including its tweet count, like what number it is. So that data's there. And we'll see some of this on the front end side. But basically, this is what it's going to allow us to do. It's going to allow us to have one-to-many mapping from a person's profile to their tweets. And so if we take a look at the likes and retweets, these are exactly the same. Like and retweet are the same exact thing. They're just different verbiage, right? Like versus retweet. But the concept is the same for both. So what we're going to do is the same thing we did with the tweets and the profiles being one-to-many, profile to tweet. We're going to do one-to-many tweet to likes, right? And so you're going to see the same exact thing. We're going to have the init for a like. You're going to use this seed prefix, right? Which is just going to be the word like. We're going to use the tweets address and the profile address. And now here's the thing. Why are we using the profile and the tweet? Well, in the real Twitter, you can't like a tweet more than once, right? So there's no reason for us to do an incrementer. In fact, it actually helps us optimize some of our reading, because what we can do is we can just say the tweet and the person who liked it hashed with the seed prefix, the word like, is going to give you that like account. And if it doesn't return an account at that address, then that person didn't like your tweet, right? So instead of having to implement a counter, that's not what we're going to do. So we are adding the incrementing value here on the like counts for the tweet, just to give it an easy way to know how many likes a tweet has, right? So you don't have to load all of the like accounts just to get that number of how many likes that this tweet has. So on like the main page, when we're looking at the likes and retweets count, that's data that we're just getting from the tweet itself. If you wanted to make this like you know how on Twitter you can click the number and it'll open up to all the different people who've liked your tweet. If we wanted to implement some of that, what we could do is basically click that button, and then we already have the tweet address, and we can use that to find all of the likes that correspond to that tweet. But in this case, we're just incrementing that on the tweet like account, because we want to be able to see it in this page here without having to load all the like and retweet accounts. So that's the only reason we're still doing that operation. But you can see our seeds are independent of that. So who's liking it? What tweet is it? Hashed with the word like. And on the retweet side is the word retweet, and we're done. And again, we're just setting the inner data like we've seen before. This is what's contained in a like. So the person's wallet that's liking it, the profile that's liking it, the tweet that's being liked, and the authority of this like. So in this case, this looks a little confusing, and I probably should have named these a little better, but I have the wallet public key as the person who's, I forget exactly what I've set this to. Let me look. Yeah, so I didn't need both of these, wallet and authority. I really just needed authority. So I've included that twice, but we don't need that. So we really only need one of these. But the point is, they both are going to represent the person who's creating this like and authorizing it. And this is also their profile. But then the tweet corresponds to who we are actually liking, like what tweet we are actually liking, right? So that's going to be it. And so you can see that when I create this like, I have to pass in my profile, and I have to pass in my the tweet that I'm liking, and then creating the like and my own signer authority here. And the reason you have to pass in the profile is because we're going to use it in the profile here. So hopefully that makes sense, guys. This is going to be a little bit hairy at first, but the point is we've got dynamically indexed data to build this app out. And so just to quickly recap, I create a profile that's one-to-one with my wallet, right? So just one seed plus the prefix of my wallet address. That gives you my profile. I can also create a tweet, and that's going to give me one-to-many of my profile versus how many tweets that I have. So profile is one seed, tweet count, right? One-to-many. And then likes, I have a one-to-many relation from tweets to likes, but I also have a mapping here with my seeds that tells me who liked the tweet and what tweet was it. Now, you don't have to do it this way. But the only reason we're doing it this way is because likes are capped at one. You can't like a tweet more than once. So we did it this way. But if you wanted to open up to allow people to just like more than once, then you could also implement the same exact counter method that we did for tweets, right? You could add like count plus one. But for the sake of our app, we did it this way because we only want to be able to like it once per profile. So that's it. That's how you set up these seeds. That's how you can set up this data. And it's all on chain, but it's findable and accessible through these derivation functions. And all of them are packed into the seed utils file. And so we'll step through some of these as we go. But that's the gist of the program, guys. It's going to just create these accounts with the proper seed derivations and the addresses. And it's going to just set that inner data and it's going to update where we kind of need it to, right? So like different counts of things like tweets and likes. So that's enough on the program side for right now. Let's focus on the front end here. So if we take a look at the front end, I've got this util file that's going to have all the operations to hit our program, and the seed util, which is going to be all of the address derivations, which is mostly just built on find program address. In fact, it's all built on that. So these are going to be essential. And in our components, I really just have Solana Twitter and then a tweet card, right? And then the right tweet box at the top. So let's take a look at Solana Twitter, for example. And I've got some stores in here as well that we're going to look at. But basically, to load all the tweets, well, let's start with the profile. To load somebody's profile, we're going to use the account store. So use Twitter account store. I don't know why I named it that, but here's the store right here to get somebody's profile. And so what we're going to do is we're just going to run util.getProfile, and that's going to look like this. Get profile, and again, this is up here is just like setting up my anchor configs like I talked about earlier. Gives us that seed util file, that seed util object. And then here is the creation of a profile. So when I first sign in, if I don't have a profile, you're going to see that there's on click create account, right? Like if I don't have a profile yet, then this is going to be the screen that I'm presented with, which is going to allow me to create an account. And that looks like this. If I just change my wallet, then you'll see what that looks like. So if I flip over to one of my other many wallets, you can see that the app will change and I'll have to be prompted to create a new account, right? And so I'm just going to refresh one more time to make sure this is all good. And so if I just do Joe2 and then I go to create an account, I will be hitting my program with the instruction to create a new profile, and I'll have to approve this transaction to do so, right? So I'll approve it, and now I'm in. And now I can still see the same tweets that we had, but now I'm on a different profile because I'm using a different wallet. It's a different mapping. So that's what we're going to see right here. That's going to use the create profile function and create profile transaction. And honestly, the cool part about that is like when you run this thing, like on click create account, it's going to do a little bit of parsing of what you put in, and then it's going to do create profile transaction, and that's going to return a transaction. And to send it, we just use the wallet adapter's send transaction function, use wallet right here. And that's going to be the mechanism that actually prompts our user for the approval button, which is going to be signing the transaction. So we don't have to code any of that. We just use wallet from the wallet adapter. And then once you write send transaction from the wallet, if you have an already pre-built transaction, then if it requires your signature, which in this case it will because we've marked it as the signer, then you will be prompted to sign the transaction. And particularly, this will usually make you the fee payer unless you specify otherwise. So you'll also have to sign for that as well, which can just be one signature. So good to know. So then once we've created an account, we can load it. And this will obviously return that there is no profile if there isn't one. So this is right here. It's set to null at first. And then we try to load the profile as a profile object, which we have in our types, right? And that's just the same thing that we entered. In fact, all of these are the same things that we entered on the Rust side. This is just what's in our data. So we can see that we set it to null, and then we try to grab it. And we first make sure the wallet's connected, and then we try to grab the profile. And so we run get profile, and we pass in the wallet. because what we're going to do inside of Git profile is we're going to actually take the wallet as input, and we're going to run the derivation ourselves inside of this function. So it's abstracted away from the front end. We don't have to worry about it. We have the wallet connected. Just pipe it into this function and get somebody's profile. And that's happening right here. So program.account.solana Twitter profile.fetch. And we get the profile pub key from the seed util, right? And that's just looking like this. We just go profile PDA, profile seed prefix hashed with their wallet public key, right? And so we know that that's going to give us their profile. So we go ahead and we pull that back. And if it gives us a response, then we can actually return it as this object. And if it doesn't, it throws an error, right? And so in our store, if we get an error, we'll just log it and we'll continue with the null value, right? So if it comes up null, then our front end knows, okay, there's no profile yet. And once it's been created, this will return us the account that we've queried, and it will give us the data inside of it. So that's one store. And then the next step is once we have a valid account and we're here, right? Like this part, being able to write a tweet, that's not really anything special, right? We just have the write card, which appears only if we actually have a valid account, right? So write tweet, we pipe in all of our props, and we're allowed to write a tweet if we have a profile. Now, and obviously that's going to contain the published tweet, which is going to be the create tweet transaction, which we pretty much know what that's going to do, right? We just go ahead and do create tweet transaction. That's going to do the create tweet function on our program. And we just have to tell it what our message is, and we have to pass in the accounts. And so one of them is going to be our profile PDA. So again, set this up so I can just pass my wallet and it'll derive everything I need from the seed util file. So pretty neat stuff. And this next tweet PDA, right? This is what's cool is notice this is an await, because next tweet PDA is going to first try to get the tweet count from my profile, right? So it's going to take a look at the profile PDA, fetch it back, and try to get the tweet count as a number. And as long as it can do that, we'll know that the tweet count, whatever it is, +1 is going to be the seed that we use to get this current tweet's address. And so get next tweet PDA, of course, that's for creating the next new tweet. So we'll all automatically increment that by 1. And so we've got that done in there. And then you can see here that we're going to just run that. We're going to get back our instruction, put it into a transaction. And again, we're going to use the wallet connector to send that. And you'll see that every time we send a transaction, we're going to just use the wallet connector because our user is going to be the one paying for this stuff. So pretty cool. And then we're going to run get all tweets finally, right? And so get all tweets is going to be another store where we're going to have the tweets loaded just like we're loading the profile. So we load the profile like this with get profile. And with tweets, we run get all tweets. And now this is a handy anchor function that they have where previously we've been looking at, like, let's say get tweet or like get profile. We could do .fetch. So we specify the account and we do .fetch. And we provide an address to get back a certain account of that structure. And for reference, if this address was not a Solana Twitter profile account, it wouldn't work because it wouldn't be able to deserialize it. So if we do that with get all tweets, instead what we can do is Solana tweet.all, and that's going to run get program accounts, and it's going to filter it by any account that's deserializable into a tweet. And so when we return from this, we'll get all the tweets that have been created on like using our program. And that's why you're able to see everybody's tweets here, not just your own, because we're fetching all of them, right? And so that's what's going on here. And so we go ahead and we grab all the tweets, we load the person's profile, right? And we just take a look, like this is just to load their profile and see if that tweet belongs to them or not, right? And we also can do it to grab their metadata. So like we can grab their username and stuff for each one, right? Like that's how I know who each person is for each tweet, I'm loading their profile. And so, that's all that's going on right there. And eventually we push that tweet into our list here and we go ahead and do that. So That's really it for getting tweets. And then if we wanted to get likes or anything like that, I have the functions here, but I'm not necessarily using them per se. You know, these functions can be used to go build onto this app and say like, hey, let's add like a page that we click the tweet and open up to and see all the likes. But I didn't want to go that hard with it. In fact, it's a great exercise for you guys to do if you want to learn like how to leverage more of these anchor commands. That's a great idea. But I did not go and like make these part of the actual build. Instead, all I really did was use like store, and I just wrote a boolean of whether or not this tweet has been liked by the current person, right? So I go and take a look, get like for the tweet, and I also pass in the wallet. And if you look at get like, we get the like pub key, we load the Solana like, we get the profile pub key, and then we take a look at the Twitter profile, pull it down, and we just see if we can get a like from this, right? So with that being said, and just so you guys know, like Seed Util is using our wallet, so we only pass in our tweet. But when we do get like PDA, it's going to hash it with our profile PDA. So it's going to look to see for this tweet, did our user like it? And then our tweet store is going to say true or false, right? So right here. And that's all that mechanism does, is gives us this white, like I saw it earlier when I liked something, it turns white. So like if I hit this like, it's going to ask me for my approval. I'm going to be creating a like, and then it's going to turn white to tell me that I can't like it anymore because I already did, right? So that's all this Boolean's really for. There's another one for retweets. But there's a ton of stuff in here, guys, about like how to interact with this program and its associated data. And the point is, all of it is built on Anchor's functions, where you can basically do program.account and you can fetch accounts of a certain type, or you can do program.methods and you can hit your program's instructions with the necessary information. And the cool part is, once we've got this person's wallet connected, we've built the infrastructure in our app through the seed util file to derive all of the PDAs that we need using just their wallet address, right? And some of them are built on top of each other, right? Like you need to derive a profile, then derive the tweets, then derive the likes, right? So there's a couple of steps, but the point is you can start with just that person's information, and you can go from their connected wallet address to all of this other data that will build out the app experience for the person. So like I'm not going to go crazy in explaining each and every one of these because they follow the same kind of pattern, but you can see that that's basically what we're doing over and over again for all these different things, right? That's how you see all the tweets, that's how you see the likes, stuff like that. And so I encourage you guys, like I said, to leverage these get like create like blah 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 and try to build on this. I think it'd be pretty fun. And also you can probably build a better UI than I did. So either way, that basically is how you do the PDA mapping for dynamic indexed data, which I'm sort of coining that term here in a sense. So you can basically create app experiences for people based solely on their connected wallet. And it's just cool because once you disconnect, the whole app disappears, right? So you can see that it's all dependent on you having that wallet connected, and using that, it can give you the full app experience. So hopefully that makes sense to you guys. Hopefully all of this is evident to you guys. And, you know, there's a couple different ways you can maybe make the UI snappier, right? There's cool improvements, but the concepts are going to be the same. And now, adding to that experience of a Web3 application, let's actually take a look at our V2 program and our V2 app. Now, for starters, on the V2 app, the only thing that's different is we've added into our function for creating likes and retweets the additional instructions of minting those tokens, right? In fact, I believe the instruction method calls on the client side are exactly the same. So we'll crack it open and we'll take a look, but the structure is exactly the same. So if I look at V2, if I crack open the util and I take a look here, you can see that the function headers, this is a new one here, but these are all the same. They just include more accounts now. But again, just like before, our seed util is really just deriving all these for us. So from our like client side, from our front end side, everything looks kind of the same. You can see that init now has a lot more stuff. And you can see this is all just like this is what we had last time, just the profile. But now we have all these. And if you look closely, all it is just mint metadata and mint authority for two different kind of tokens, the like token and the retweet token. And since we're creating tokens that are PDAs also, we don't have to worry about storing this mint address anywhere or keeping the private key of the mint anywhere or the mint authority, blah, blah, blah. It's all deterministically created from our program. So this is actually going to be really cool to see how you can do this with tokens and mint authorities and stuff like that. But we're following similar concepts to before where we just have a set of seeds that we can deterministically use. And if you look closely, we actually don't need the person's wallet address or profile to get these, right? These have nothing to do with who's logged in or whatever. It's just here's the like mint seed, here's the metadata derivation that every metadata follows, and here's our mint authority seed hashed with the mint, right? And we'll see what that looks like close up. But the point is, guys, everything on the front end is exactly the same. Our components are the same. We still run the same thing. Create profile, right? Like this all looks exactly the same. Nothing has changed. All we do is we're hitting the same functions, but in our util file in app v2, and in there we have all these additional accounts. And I believe even the parameters are the same. It's just adding all the new accounts so we can add token interactivity. So because everything's the same on the client side, I'm going to focus solely on the program. But I will mention that the only new function in here is create mints. And as you can kind of predict, all that's going to do is create our mints for the very first time so we can start using our app. And that's really going to be it. So it's just going to create a like mint with its metadata, with its mint authority, and it's going to do the same thing for a retweet. And that's what's going to give us those neat little tokens that we saw inside of our program, inside of our wallet. So there's a retweet one right there. So let's take a look at the program and we'll see where this kind of goes off the rails and differs from the previous one. So you'll see a lot of the same functionality is still there, right? So we've got the two create mint functions. But after that, we've still got the same four functions, right? Like same four things, creating a profile, tweet, like, retweet. And if we look very closely, especially at the state, those things are the same. The state is the same. We got the same fields, same everything, right? And then when we go to create a profile, it looks exactly the same. But now here's where things get interesting, right? So we have to get a user set up with associated token accounts when they join this platform. And now let's set the stage here for what's happening. So we know all of the PDA derivations that we did. We're going to be able to find all of their Twitter, on-chain data that corresponds to our app through our program, through all those seed derivations. But in order to be able to drop people tokens and do stuff like that, we have to leverage what are called associated token accounts. And for those of you guys who don't know, on Solana, a token itself is just one account. It's called a mint. And using that account as the identifier of that mint, we create various other accounts on Solana that describe things about that mint. So one example is like metadata. So if you have like a token that has like an image or like a symbol or an NFT that has artwork, that all belongs in the metadata of that token. So you have a mint, that's the token, and then a metadata that describes that mint. And it just is a separate account that just points to it, right? And it's actually derived that its PDA address from the mint address. Same thing goes for an associated token account, which is the account that represents your balance of that token under your wallet. And so think about it, it's just a pointer. Like we saw the like setup, right? Where a like is basically saying, let's ignore like this one and these for a second, right? Like if we just ignore these and we take a look at those two fields, all a like really is just a relation between a profile and a tweet, right? And then if we wanted to be able to like a tweet multiple times, you could just add like a field that says like count. or balance, right? And so the number of likes that my profile has for a particular tweet is this balance. This is exactly how associated token accounts work. It's an account created that says the number of tokens I have in my wallet for this mint is this balance. That's it. That's all they do. So, with that being said, when you want to send someone a token, that account has to exist for their wallet for you to be able to send it to them. And you can create it for them. You can pay for that. You can set them as the owner, but you pay for it. That's totally fine. And so we could do that in our app. When we click the like button, we could be creating that person's token account. But I actually chose to do this a little bit differently because the way I saw it was if you're going to onboard to this Twitter program, this platform, you're expecting to receive tokens based on your likes and retweets. And those are pretty common. Like people like and retweet stuff pretty often. And you only need to create this associated token account once, right? So rather than having a check every time somebody wants to like your tweet, rather than having a check and a possible creation of that account into that instruction, I thought it made more sense. And this is totally optional for you guys as your design implementations. I thought it made more sense when I create a profile, it creates for me those two associated token accounts as well. And that way I pay for the creation of those, I pay for the creation of my profile, and now I'm fully prepared to receive airdrops. So that's exactly what we did. When you create a profile, we are actually going to also initialize the token account for your likes and the token account for your mints or your retweets. I'm sorry. And so in order to derive those, though, what we need to do is we also need the presence of these other accounts. So these are exactly the same, like and retweet, but let's take a look. So first, we need the like mint to know what the associated token account is going to be, right? So in this case, you can see here is the token account for a like. And so you can see the authority is going to be my wallet. The mint is going to be that mint. And again, I'm going to be the payer that creates it and we're initializing it. Same thing with the retweet, right? Looks exactly the same. And then from here on down, at least until we get to these additional programs, everything's the same as it was, right? We're just creating this profile exactly like we did before. So that's cool. Now, another thing too is the mint authority. So here's another really cool topic that we've covered in this example as well. When you have a mint authority, that means somebody is designated as the authority who can mint new tokens, who can introduce new versions of this mint into the supply. And so you can make that whoever you want. You can make that yourself. And then every time you want to mint new tokens to somebody, you have to sign for that. You have to authorize that. Or you can make the mint authority null. And that means no new tokens can be minted ever. And that's what happens with NFTs. Optionally, what you can also do is you can delegate the mint authority to your program. And you can allow your program to control minting of new tokens. And the key here is that's not by default a secure thing. You have to code in the minting of new tokens, right? And it can only happen through your program if your program is the mint authority. And I'll tell you why. So basically, if you look here, our mint authority for the like token is a PDA. You can see the seeds that we use, and we saw these on the seed util function as well. So if we look at creating a mint, you can see here creating a like mint. So here's the like mint. We're initializing it with anchors in it. We're making it a PDA, so it has, a program derived address from this seed, but we also are designating that it's a mint, has 9 decimals, and the mint authority is this like mint authority, which we're also initializing, and it's also a PDA. So what does this mean exactly? Well, if I want to mint new tokens and I am the mint authority, my wallet with my public key and my private key, then I would need to sign that operation. If you wanted to mint new tokens, my signature needs to be in that transaction to authorize you minting new tokens. When a program's PDA is that mint authority instead, then the only way to add a signature, so to speak, for that mint authority is to use this invoke signed function and provide the signer seeds like we saw before, right? And right there are the seeds we use to create this mint authority PDA, right? And so the only way you can allow minting of new tokens is through your program, because the only way you can do a sign or seed invoke signed is from in your program, right? Like you can't do that off chain. This is something a program has to do with a CPI call where it's invoking another program. And that's something that just the program can do. So the reason I say it's not secure by default is because if you have an instruction that says mint new tokens and anyone can hit it, and it doesn't matter who the signer is because the mint authority is a PDA, then I could just mint a million tokens if I wanted. I could just keep hitting your program and minting tokens. So you need to have some kind of gating around that. And in our case, you are only minting somebody a new token when somebody pays to create a like. And that's the only code in our program that allows minting of new tokens. It has to have all those other pieces in it. And we'll see that in a minute. But basically, that's what's cool about this is the mint authority is a PDA. And so our program can control the minting of new tokens, as it will do when you issue somebody a like. The program will mint them new tokens. And you'll pay for the cost of that, but you don't have to authorize it. So moving right along, the last piece of this right here to create the mints is everything's being done by Anchor in this context. And down here's the retweet one, same thing. So this is the two inits, right? We're initializing the mint authority, but we can't do init on the metadata yet. And at the time of this recording, actually, I believe it is now supported in Anchor version 0.26, but I did at least 0.25 back here when I built this, and I was not about to go redo the whole thing. So you might be able to do that now. But regardless, when you weren't previously, you had to do it manually with invoke signed. This is us just invoking the metadata program and establishing the metadata for our mint, right? And we're doing that with a number of constants. And you can see, again, the mint authority is that same account. And this is signed by the mint authority as well. So that's all that's happening here. We're creating these mints for use on our program. And we only have to run this one time to create these things. And because they're PDAs, the nice thing about having the mint itself be a PDA as well is you don't have to worry about keeping track of a mint address, and you don't have to worry about collisions. So if I just run this one time and create the tokens, if I was using a random key pair every time, then I would have to take that new key pair or that new public key that was created for the mint and plug it into my front end and reload it. This instead, if you run this and the mints already exist, it'll just error and tell you, hey, these accounts exist already. And then you can say, oh, we're good. These mints exist. We can just run the app. So pretty cool stuff. But anyway, guys, not to go into too much detail on the mint stuff, but just to talk quickly about what's in the metadata accounts, you can make these just empty. You know, you can do whatever you want. I decided to stick a little bit of information in there. So like, this is just like my way of storing the metadata constants, probably not even necessary. But this is my way of keeping track of just a couple things for the mint authority PDA. So we've got the bump for itself and the mint bump. And that way we can reference those fields if we need to. And the reason I'm storing both here is because you can't store custom data in a mint. You can store it in the metadata, but a mint has a very specific data structure, and that's what makes it a mint. It follows a standard, the SPL standard. So we're going to store both those just in our metadata account because we can put whatever we want in that, or I mean our mint authority account, because we can put whatever we want in there. So I know I'm throwing a lot at you guys, but the point is, to simplify it, we're creating some tokens that are going to be used on our platform, and their mint addresses are derived from our program address so that we don't have to worry about keeping track of a new random mint address. We are also allowing our program to be able to mint new versions of this token, introduce new tokens to the supply based on functionality from our app and our instructions. And that's really all that this is set up to do. A little bit verbose, but that's what it does. And so going back to our create profile, like I said, we are going to just initialize associated token accounts for each of those mints when we create somebody's profile. And you can see they're going to just pay for those creations on signing into the platform. So once you join Solana Twitter V2, you have the 2 token accounts that you need to be able to receive the airdrop tokens, and no one has to worry about checking to make sure those exist or creating them ahead of time. You already have them. So you're ready to go to receive airdrops. Now, creating a tweet looks exactly the same as it did before because that has nothing to do with likes or retweets or tokens. So there's no changes here. Still creating a tweet the way that we're familiar with. And now here's where things get different. Here's where the magic happens. Creating a like is under the hood the same thing that we did in V1. So if you take a look, we've got our tweet, we're deriving it from the seeds again. In this case, we're checking the seeds, right? And we're looking at all of this other stuff here. But like I said, the like itself, if I can find it, is right here. We're initializing the like. We did this before, right? And I changed this to the word submitter profile, so it was a little bit more clear whose profile it was. But same thing, right? Profile, tweet, same order, same seeds, same seed prefix, the word like, just like we saw before. Only one person can like one tweet once. So, or one person can like a tweet once. Many people can do it, but these are the seeds that we're familiar with. What we've introduced now is the tokens being transmitted over to the person who wrote the tweet. So you could do this where like somebody has a bunch of like tokens, and whenever they create a like, they actually are sending the tokens there. And if you're out of like tokens, you can't like any tweets anymore. You could do it that way. But I decided to just let people like whatever they wanted, and new tokens would get minted every time. So that's what's going on here. So we pass in the like mint, so we know what mint we're using. We pass in the like mint authority because it needs to authorize the creation of those new tokens. And then we derive the author's token account so we know who we're airdropping to, right? And then you can see here that if we look up here, mint2 is the function that we're going to run. So up here, this is what we saw before, right? Creating a like. We still have the like data on chain like we've seen before, but now we just have this additional step of minting to the author. Excuse me. And so this is where the magic happens as far as like what we're doing as far as like minting the tokens to this person. So if you look here, mint2, here's the mint that we want to send. Here's the author's token account we want to send it to. And here's the mint authority that's going to authorize the creation of new tokens. And now again, like we saw with that metadata function, this CPI, cross-program invocation, is being signed by our program using the seeds. It's being authorized using the seeds. And this is what I was talking about where it has to happen on your program. But as you can see, the only way anybody could hit this function is by passing in a token account to mint2 and, issuing their mint and passing in the like mint authority, which they can derive all that stuff, no problem. But the thing is, once they go to create a like for a certain tweet, like somebody could probably game this instruction by just passing in a different tweet every time, but the same token account, right? That's one way they could probably game this. And that's just some stuff that you got to think about, edge cases like that and whatever. But the point is, the way you design this kind of thing is you want to protect your minting being done by the program by something that can't be gamed. In this case, it probably can be, but ideally you want to make sure that nobody can just pass instructions to your program, because people could do that from anywhere, and be able to mint new tokens to themselves over and over again at will, right? So regardless of the level of security of this program, that's exactly what's going on here, man. You've got the mint2 function follows after we've created a like, and this is going to just airdrop a new mint token to somebody's token account, right? And that's it. And the same thing happens for retweets, right? So same exact thing over here, right? We're just dropping those in there. And so that's what's pretty cool about this new version is we've just interlaced the token functionality. And that's all it really is, man. It's just when I create a profile, it just sets up the associated token accounts. I have to first create the mints and mint authorities and metadatas ahead of time, but I only have to do that once. And then when I go to create likes, there's just this additional step of minting somebody some tokens that already exist because we did it once and created them. And you can see we're just minting one every time. And that adds an instant layer of tokenization to your app. And so you can have like all kinds of cool stuff, like I said, like rewards, unlocks, reputation, things like that. And so it's really, really cool. And so if we take a look here, I didn't add any functionality to the front end as far as like reading what tokens you have, things like that. It's all just in the wallet. So I kind of left it to the wallet itself. Whoops. And all I'm going to show you again is that token, right? But I left it to just look at the wallet itself. But like I said, here in the seed util stuff, that's where things look a little bit more beefy because we're deriving all these things. And then with our functions, you can see that we have all those additional accounts for the mints, right? So creating a profile, here's all the token accounts. And then creating a like, we can see here's the token accounts and the mint and stuff like that. But that's really it, guys. I know there was a lot to unpack. This is actually something I would sometimes run in two different workshops, depending on like the experience level. Or if we have enough time, I would just run the whole thing. But just remember, like version one, we basically introduced the idea of having dynamically related data, indexed data, one-to-one mapping to your profile from your wallet, one-to-many mapping from your profile to the tweets that you've written, and one-to-many mapping from your tweet to the likes it's received, but isolating the number of times you can like one tweet to one. And we did that all through just seeds and through PDAs and through Solana's like internal mechanisms of creating account data. So that's been really cool. And then in V2, we took the same program, the same app, same index data, and we introduced the concept of adding tokenization to the platform. Airdrops. That's basically all we did was airdrops. But we made those mints also PDAs. So they were easy to keep track of. We could derive them at any time. And we can confidently know that they've been created and exist when we go to first initialize our app for the first time. And we also, on that note, added a mint authority that was our program owned account. It was a PDA, so our program was able to control minting of new tokens. So guys, I hope you learned something. That was definitely a lot. And despite my questionable UI, this application is actually very robust, and you can use all of the internal like infrastructure of the front end and the program to build on and do some really cool stuff. Later.